Hey math kids, today we're going to talk about the vector product of two vectors. And so I just want to do a quick definition. So when we were saying A times B, we were calling that either the dot product or the scalar product. And then when we do this, we call it either the cross product or the vector product. Okay, and it's also important to note that the vector product is only defined for three-dimensional vectors. And there's actually two ways that we can do the vector product, and we have two examples, and we'll do one using each method. Okay, so we have let's talk about one other thing. So some properties. These are all vectors. I'm not going to draw the arrows on top of them though. So if we do A cross B, which once again those are both vectors, they are perpendicular to both A and B. If we do A cross A, that equals 0. If we do A cross B, and we want to flip it around, we have to put a negative sign out in front of the second one, the one that was originally the second one. That's in contrast to A dot B, where we can actually move those and it doesn't change their value. If we do distribution, this isn't distribution. If we do A dot a cross product, this is called the scalar triple product. And if we distribution holds up, just make sure you're strict with order, like that. And then this kind of distribution also holds up. We had A plus B cross C plus D. It would distribute just how you think. Just make sure you're really strict with the order because of this rule. Okay. Now I'm going to write down the first definition of cross product. So A is defined as A1, A2, A3. B is defined as B1, B2, B3. And then A cross B is defined, and good luck memorizing this, A2, B3 minus A3, B2. All right. So now let's try that with some numbers. So A is going to be defined as 2, 1, negative 1. B is defined as 1, 2, 3. And C is defined as 2, 0, 4. And we are asked to find B cross C. All right. So we're looking at these two. So B is the first one. So B is like our A over here, and C is the second one. So that's like our B over here. All right. First one, spot 2 is a 2. Second one, spot 3 is a 4. First one, spot 3 is a 3. Second one, spot 2 is a 0. First one, spot 3 is a 3. Second one, spot 1 is a 2. first one 1, third one 4, first one 1, second one 0, second one, first one. Okay, now we just need to simplify that. So that's going to be 8 minus 0, 6 minus 4, 0 minus 4, which gives us 8, 2, negative 4. Alright, so the cross product is that. Now, they want us to find A dot B cross C. So we already know what B cross C is, so I'm going to just plug that in. 8, 2, negative 4. And then we know what A is. It's right here. 2, 1, negative 1. And we're going to do the dot product, which is where we multiply common terms and then add them. Negative 1 times negative 4 is positive 4. So that is 22. Okay. Now I'm going to write down the other definition, which is, once again, A is defined as A1, A2, A3. B is defined as B1, B2, B3. And A cross B is defined as A1, A2, A3, B1, B2, B3, and it's I, J, K. So this translates into A2, A3, B2, B3, and that's I minus A1, A3, B1, B3 for J, and then K is A1, B1, A2, B2. Now, each of these, we haven't really seen this before, but if we have A, B, C, D, that's equal to AD minus BC. Alright, so let me write down the next problem, and we'll do it this method. So this time A is defined as 1, 2, negative 1, and B is defined as 1, 0, negative 3. So the first thing is we're just going to plug it all into this. So we're finding A cross B is what we're doing. Well, it says find all vectors perpendicular to both of these. And so we're just going to find the cross product first, and then we'll talk about it. Okay. So like I said, I'm going to plug it into this. So let's set it up. Okay, A2 is 2, negative 1, 0, negative 3, 1 and 3, so 1, negative 1, 1, negative 3, 1 and 2, 1, 2, 1, 0. Okay, now each of these we need to write down, we need to use this thing. So we do this diagonal first, and then we subtract it from this diagonal with multiplication. So we get negative 6 minus 0 minus negative 3 minus negative 1, 0 minus 2. Okay, so that's negative 6i. This is going to be a plus sign, so that's negative 2. The negative 2 times the negative is going to be positive 2j. And then this is minus 2k. So if I put that into component form, it's negative 6 to negative 2. And so we can actually factor out a 2 from all of those. So we could rewrite that as negative 3, 1, negative 1. And so no matter what this scalar is, it doesn't matter. So all the vectors perpendicular to this are going to be this. Technically, we could put a k here and say the same thing, because it'd just be everything times by 2. Yeah, because we could fix it by dividing, like doing a fraction and things like that. But yeah, that's it on that one.